Right, in that same section of oxidation and reduction, there's a wee stage where you have to come up with a formula for the compound given the oxidation number of the transition metal. So each of these is a transition metal compound and they give the oxidation number in Roman numerals that we've seen before. Now there's two ways that you can do this. You can use your oxidation number. I'll show you the way I prefer, something you've seen before anyway, is using your valency or Hooke's. So this says iron 3 sulfate. Now sulfate is one of those radicals, but you just have to remember. Radical, man. SO4 2 minus. So iron 3 Fe, and once we see that it's 3, I put in 3 Hooke's. Sulfate is SO4 2 minus, so it has 2 Hooke's. Now you've just got to match them up. So there's my sulfate going in below. I'll need another sulfate. It always comes with 2 hands. We've 1 extra, so we fire in another 3 because the iron always comes with 3, and therefore we need another sulfate. And they match up now. They're all linked together. So what have we got? We've got Fe2 SO4 3. Now that looks a wee bit strange. Got to emphasize that it's 3 of these sulfates. So put brackets around them. And this 9 water just means it's a hydrated substance, 9H2O, just like your hydrated sodium carbonate. Titration, where you just fire down the water at the end. The other way, I'll show you one of these and I'll not do it again, using oxidation numbers. We see here that iron has an oxidation number of +3. Sulfate, you've got to know, because 2 minus is -2, so you've got to get them the same. So you're going to bring it up to 6, the lowest common multiple of both of them. How will you bring that up to 6? You're going to need 2 of the irons, like I wrote down there, and 3 of those. So some of you might prefer that. Might show you one more time then. So Fe2, SO4, and again 3. So you're just looking at the numbers and seeing what they both go into. But since we've looked at valencies and Hooke's before, I can't see why you wouldn't use it. Next one, chromium 3 chloride. So chromium, Cr, that's telling you how many Hooke's it's got. It's got 3. Chlorine, group 7, has 1. In order for these to match up, 1 chlorine, we need another chlorine, we need another chlorine. So your formula is CrCl3. If you're using the oxidation number way, it's much the same. Chromium is +3, chlorine is -1. What do we do? It's nearly like simultaneous equations. Times that by 3, CrCl3. Either way, that's why it's in this section on oxidation reduction. You can do it like that. Manganese 4 oxide, Mn. IV means 4 Hooke's. Oxygen's group 6, comes with 2 Hooke's, or -2 is your oxidation number generally, in order for them to match up. You need another oxygen, therefore it's MnO2. Or if you prefer, manganese +4 given by the Roman numerals, oxygen 2 minus, so you need 2 of these to match up, MnO2. Iron 2 chloride, so Fe, 2 Hooke's, chlorine, 1 Hooke. There's one of my chlorines, you need another one, so therefore FeCl2. Just pause the video maybe, try these. That's just sulfur there. That's your radical sulfate. That's your radical sulfate. That's just sulfur. So continuing on here, nickel comes with 2 Hooke's. Sulfide is just sulfur, but when bonded together, it becomes known as sulfide. It has 2 as well. And then when it's bonding together, it becomes NiS, nickel sulfide. Cobalt 2 chloride, cobalt, 2 Hooke's, Chlorine group 7, 1. So therefore that's going to become COCl2. Iron 2 sulfate. Iron, valency of 2. Sulfate's your radical, SO4 2 minus. 4 and 2 is 8. It's also got a valency of 2 shown by that. They match up. Therefore, Fe SO4 7H2O, if you like. And then copper 1 sulfate. Copper, Cu, valency of 1. Sulfate, SO4 2 minus. Valency of 2. Copper, we need another copper there. So Cu2 SO4 is your formula for copper sulfate. So continue on here, looking at what is oxidized and what is reduced. We'll also identify what's the oxidizing agent and what's the reducing agent by using oxidation numbers. So ignore these numbers, the big numbers up front. That's just telling you your molar ratio. So 2:1:2, nothing to do with moles here. We're looking at the charge that an atom appears to have. So these numbers here have no relevance in your oxidation numbers. So generally when I'm doing these, I leave a space above and space below. So give yourself plenty of room. Filling in oxidation numbers in SO2, sulfur dioxide. We don't know sulfur, but we know oxygen. Oxygen there is going to be 2 times minus 2. We're at minus 4. Overall, that there compound is neutral. So we're at minus 4, having to go to 0. So sulfur must be plus 4. Oxygen, when it's on its own, 2 times 0. Remember, like I2, Br2. Don't write 2 times minus 2, otherwise you'll need to charge a minus 4 up there. And over on this right hand side, 3 times minus 2. We're at minus 6, sulfur must be plus 6. Now you match up atoms where there's a difference in it. Now what I mean by that, well, this is where I should have left the space actually above these numbers. It's been a while. You've gone from sulfur at plus 4 to sulfur plus 6. So what's happened to your oxidation number? It's increased. And how is it increased? It's lost electrons. So this will take a wee bit of time getting used to, but it's crucial when we look at balancing these. So what has it done? It's gone from plus 4 to plus 6. Loses 2 electrons. And remember, this is where it's going to come in, oil rig that we mentioned way at the very start of the first video. Oxidation is loss of electrons, reduction is gain. There we're losing it. Loses 2 electrons, therefore oxidized, therefore the reducing agent. So a reducing agent is something that allows reduction to happen by losing electrons itself. So in order for a substance to gain electrons, some other substance must lose the electrons. And there's going to be a change somewhere else. Oxygen here, minus 2 to minus 2, there's no change, so don't take that. You're looking at the one up here. Always one on the left hand side of the arrow and one on the right. It goes from 0 to minus 2. How's it done that? Gains 2 electrons. When it gains the electrons, it's reduced. I'll leave a wee bit more space the next time. Therefore, the 3 reducts. It's the oxidizing agent. Now if they ask you specifically what is the oxidizing agent, be precise. Write it down. The oxidizing agent is O2 and the reducing agent is SO2. I'll do another one. So H2 plus O2 gives you H2O. Again, ignore the big numbers. That's all to do with moles, not to do with moles. We're looking at charges of atoms. So H2, it's neutral, so it's 2 times 0. O2, 2 times 0 as well, the 2 just coming from the molecule itself. And then here, hydrogen is 2 times plus 1, oxygen's minus 2. Now in order for one substance to lose electrons, another must gain, and you match up like atoms. So match up hydrogen and hydrogen, oxygen with oxygen. So say I'm taking my hydrogen, which has an oxidation number of 0 here. It then goes to have an oxidation number of +1. What's happened to my oxidation number? It's increased. It's increased, therefore it's oxidized. So it's went from 0 to -1, loses 1 electron. Therefore, using my oil rig now, therefore it's oxidized. And opposite to what we might think, it's the reducing agent. Now O2 here, it's gone from 0. If it's lost electrons, this must gain electrons. 0 to -2, it has gains 2 electrons. Oil rig now, therefore reduced, therefore oxidizing agent. Be precise now, right down below, what's your oxidizing agent? You can write out the full word, just trying to save a wee bit of time. Your oxidizing agent is O2, your reducing agent is H2. Third one here, C plus O2. So C, there's no charge in it. It's an oxidation number of 0. O2, 2 times 0. And CO2, it's a compound. We can fill in oxygen. 2 times -2. We're at -4. We want to get to 0. That must be +4. Now match them up. Goes from 0 to +4. How's it gone to 0 to +4? It's an increase in oxidation number. Therefore it's oxidized. So loses 4 of those negative charges, loses 4 electrons, therefore oxidized, therefore reducing agent. While O2, it's went from 0 to -2. It's gained 2 electrons. Therefore reduced, therefore oxidizing agent. I'll be precise again. So the oxidizing agent is O2, while your reducing agent was this carbon. This all goes back to, these are known as redox reactions. Remember the RE just mean, or RED just mean reduced, and your OX just meaning oxidized. So it's only deemed a redox reaction if one substance loses electrons while another substance gains electrons, like we've had so far. Now a few trick questions might say, is this a redox reaction? And not. One substance doesn't lose and another substance doesn't gain. This one, PCl3 compound, you can fill in your chlorine, 3 times -1. So your phosphorus there must be +3. There, no charge, 2 times 0. PCl5, 5 times -1. Phosphorus +5. Matching them up. Phosphorus goes +3 to +5. How's it done that? Loses 2 electrons. Therefore oxidized. As the oxidized, it's the reducing agent. Chlorine, -1 to -1, there's no change there, so we don't match them up. Here, 0 to -1. It's a reduction in the number, so it's reduced. And when it's reduced, it gains. So it gains 1 electron. Therefore reduced. Therefore oxidizing agent. So be precise down here. Your oxidizing agent is Cl2, while your reducing agent is PCl3. Do maybe 4 more here. Again, you can pause it, try them yourselves, but I just think they're getting a wee bit more difficult as we go along. Here, ignore the big numbers, fill in your oxidation numbers of your compounds. So hydrogen, 2 times plus 1, that must be 2 times minus 1. Oxygen, 2 times 0. Here, oxygen 2 times minus 2, we're at minus 4. When I get to 0, that's plus 4. And water, 2 times plus 1, and oxygen's minus 2. Now matching them up, carbon, is there any difference? Minus 1 to 4 there is. Minus 1 to 4, what have you done? You've lost 5 electrons. Therefore oxidized, therefore reducing agent. Doesn't matter which one you start with. Hydrogen, plus 1 here, plus 1 here, no difference. It's a spectator ion, so it's just watching, doesn't take part. Oxygen here, 0 to minus 2, 0 to minus 2. That's perfect. So there is a difference. 0 to minus 2. It's a reduction. The reduction in price got smaller. And using this, it's a reduction, it gains electrons. Gains 2 negative charges. Gains 2 electrons. Therefore reduced. Therefore oxidizing agent. So always write down below now, your oxidizing agent is O2, whereas your reducing agent is C2H2. This one, iron 2 going to iron 3. Iron is the oxidation number is the charge on it, so plus 2. Chlorine 2 times 0, because the charge that one single atom appears to have. Iron 3, chlorine is minus 1. Iron went from plus 2 to plus 3. How's it done that? Loses 1 electron. Why rig now? If it loses electron, it's oxidized, and therefore it's the reducing agent. Chlorine, on the other hand, if this loses, something else must gain them, and it has. It gains 1 electron, and we'll show you how to balance these very shortly. Gains 1 electron, therefore reduced, therefore oxidizing agent. So down here, write them down. The oxidizing agent is Cl2, whereas your reducing agent is Fe2+. Always the reactant on the left hand side. 2 more. Zn, so it's 0. It's got a text after reply. Zn, 0. Copper sulfate. Difficulty 1 because this is your radical. If you want to think about it, it's SO4 2 minus. So that is 4 times minus 2. We're at minus 8. You want to get to minus 2, so that must be plus 6. So your sulfur is plus 6. 4 times minus 2 is your oxygen. There's your copper, must be plus 2. Just have a wee check for yourself. 6 and 2 is 8, minus 8 is 0. Same down here, your zinc sulfate, 4 times minus 2. Your sulfur is plus 6. Your zinc must be plus 2. And down here, copper, there's no charge on it, so 0. Matching them up. Is there any difference? There's going to be a few spectators here just watching, sitting back, relaxing. Zinc goes from 0 to plus 2. Lovely. There's a difference. What's it done? It loses 2 electrons. Therefore it's oxidized. And if it's oxidized, it's the reducing agent. While over here we have copper, plus 2 to 0. See there, oxygen staying the same, sulfur staying the same. So plus 2 to 0, it's a reduction in number. It's reduced. If it's reduced, it gains 2 electrons. Therefore reduced. therefore oxidizing agent. So write them down now. The oxidizing agent is CuSO4, is it? Whereas the reducing agent, just where the reduction is taking place, or the oxidation is taking place, sorry, is Zn. And one more example, we're looking at potassium manganate 7, potassium permanganate, or MnO4 minus. Again, ignore the big numbers, that's all to do with moles. We're just looking at individual atoms. Start with your oxygen, 4 times minus 2, we're at minus 8. You want to get to minus 1. Minus 8 to minus 1, you add on 7. Hydrogen, H plus, just a plus 1. Oxygen, 4 times minus 2, we're at minus 8. You wanted to get to minus 2. Minus 8 to minus 2, you add on 6, and 6 is being split amongst 2 of them. So 2 times plus 3. So take your time filling these in. Mn2 plus, just the charge on it, plus 2. CO2, 2 times minus 2, minus 4. You want to get it to 0 because there's no charge, so you're adding on 4. And water, 2 times plus 1, minus 2. Generally, the ones that are changing are your different sort of atoms, so your manganese and your carbon. Oxygen and hydrogen generally will stay the same, bar the first few examples there when there's just hydrogen and oxygen and so on. So Mn going from plus 7 to plus 2, it's a reduction. When it's a reduction, it gains 5 electrons. Difference between 7 and 2 is 5. Gains 5 electrons, therefore reduced, therefore oxidizing agent. Potassium permanganate or potassium manganate 7 is a powerful oxidizing agent. I may write it down now because I think my phone's going crazy with storage. Oxidizing agent, MnO4 minus. And my C has gone from plus 3 to plus 4. Lovely. Loses 1 electron. Therefore oxidized. Therefore reducing agent. So it is a redox reaction. So my reducing agent is C2O42 minus. Any questions on that? Let me know.